integration by trigonometric formulae, or trigonometric integration if you want to be a loser. We have 3 questions here. Each has to deal with a certain inverse trig function. Arctan, arcsecant, arcsine. There's a way to prove all 3 of these. And that's using trigonometric integration. So, we start off by looking here. So we know that this is x squared plus 9. So we'll say that this is in the form of x squared plus a squared, where a is a constant. So in this case we use tangent when we're doing this. So we say x is equal to a, and since 9 is a squared, a would be 3. We're using tangent, so we're going to say tangent and then theta. So x is equal to 3 tangent theta. Then we take the derivative to get dx. And so dx is equal to 3 times the derivative of tangent theta, which is secant squared theta, times the derivative of the inside function theta, which is d theta. So now we just set this equal to the integral, and now we just substitute it. X is equal to 3 tangent theta. Well, that's simple enough, but first let's put the top on. So dx is equal to 3 secant squared theta d theta. So we're going to put 3 secant squared theta on the numerator, just like that, and then we're going to plug in our x, which is 3 tangent theta. So that's 3 tangent theta squared, which is 9 tangent squared theta plus 9, and then d theta. So now that we have our changed function, now we're going to bring out the constant value of 9. So that is going to be equal to 3, well, let's bring out all the constants. 3 over 9 integral secant squared theta over tangent squared theta plus 1 d theta. Now, we know from pre-calculus that a property of tangent, and that the relationship between tangent and theta is that tangent squared theta plus 1 is equal to secant squared theta. So here we have tangent squared theta plus 1, which is secant squared theta. So this just cancels out. So now we're just left with 1/3 integral d theta, which is just equal to 1/3 theta plus c, plus a constant value c. So now we're going to plug in our theta. So we're going to say theta is equal to, well, that's x over 3, and then we take the arctan. So theta is equal to arctan x over 3. So that means that this is equal to 1/3 arctan x over 3 plus constant value c. So that's the answer to number 1. So now we're going to try the second one. Here we have our second question, which is the integral of x over the square root of x to the 4th minus 64 dx. So here we have x to the 4th, and that is our x squared. So x is going to be x squared. And that's equal to, this is the configuration for secant, and a is 8 because a squared is 64. So x squared is equal to 8 secant theta. Now take the derivative of both sides. 2x dx is equal to 8 times the derivative of secant theta, which is just secant theta tangent theta, times the derivative of the inside function theta, which is just d theta. Then we just divide both sides by 2. And now we have x dx is equal to 4 secant theta tan theta times d theta. So now we're just going to put that in. So this is going to be equal to, and now we substitute everything in. So x dx is 4 secant theta, so let's bring out that constant. Let's bring out that constant right there. And then x dx is secant theta tangent theta d theta. And then our denominator is still going to be square root of x to the 4th minus 64. But x squared is equal to 8 secant theta, so that's going to be squared, so that's 64 secant squared theta minus 64. So you can take out the square root of 64, which is 8. So then we take that out. So that's 4 over 8 integral secant theta tangent theta over the square root of secant squared theta minus 1. So remember the relationship between secant theta and tangent theta is that tangent squared theta plus 1 is equal to secant squared theta. So that means that secant squared theta minus 1 is just tangent squared theta. We can just cancel out secant squared theta minus 1, the square root of that, which is just tangent theta, with tangent theta. And now we're just left with 1/2 integral secant theta d theta. And the integral of secant theta d theta is just, well, now we just maintain the 1/2. And then we just, well, the integral of this is the ln of secant theta plus tangent theta plus c, plus a constant value c. So that is the integral of this. So now we just need to plug in, well, we know secant theta is equal to x squared over 8. So that's an easy substitution there. And now we just need to find tangent theta. So we can do that using a right triangle. So then we say this is theta. So if secant theta is equal to x squared over 8, then the hypotenuse is x squared and the adjacent is 8. So tangent is opposite over adjacent. So that's also this squared minus the square root of this squared minus that squared. So that's x squared minus 64. The square root of x to the 4th minus 64, which coincidentally is this value right there. So now we're just going to substitute this in to here. So now we're just going to find tangent theta is equal to opposite over adjacent, so that's the square root of x to the 4th minus 64 over 8. So that means that this is equal to 1/2 L natural log secant theta x squared plus 8 and tangent theta square root of x to the 4th minus 64 and then over 8. And then plus a constant value c. That's our answer to number 2. And so here we have our third and final question. The integral of x over the square root of 2 minus x squared dx. So we'll start with our x is equal to, because it's x squared, so the square root of x squared is just x. And so a squared is 2, so the square root of a squared, 2, is just square root of 2. So that's the square root of 2. And then this is the configuration for sine, but for the arc sine. So this is sine theta. Okay? So now that we've done that, we'll just take the derivative of both sides. Dx is equal to the square root of 2 times cosine theta times the inside function, which is just theta, so that's d theta. So now all we have to do is substitute in the values, bring out any constants, so we have the square root of 2 over, the square root of 2 integral. X is the square root of 2 sine theta. And then here we have cosine theta d theta, so we're going to do another cosine theta, and then d theta, and then that's over the square root of 2 minus x squared, so that's square root of 2 sine theta squared, which is just minus 2 sine squared theta. So then you can take out the square root of 2, so that becomes 1, that becomes 1. Oh, the square root of 2. Oh yeah, square root of 2 times sine, right? And so that cancels out with this one on the top. And so we still have this one on the outside. So that's the square root of 2 integral sine theta cosine theta over the square root of 1 minus sine squared theta d theta. And now the square root of 1 minus sine squared theta is cosine squared theta. Well, 1 minus sine squared theta is cosine squared theta. This is the square root of that, it's just cosine theta, so we can cancel out the cosine theta. So now we're just left with the square root of 2 integral sine theta d theta. And we know that the integral of sine theta is negative cosine theta. So this is equal to negative square root of 2 times cosine theta plus a constant c. And so now, all I have to do is just find theta. Divide both sides by x over the square root of 2, take the arc sine, so theta is equal to arc sine x over the square root of 2. So that means that this integral is equal to the negative square root of 2 times arc sine, well, times cosine of arc sine x over the square root of 2 plus c. And so to find cosine of arc sine, we just need to use the triangle method. So if sine of theta is x over the square root of 2, here's theta, so then this x, and then the hypotenuse is the square root of 2, so this is equal to the square root of 2 minus x squared, which is that. So then that means that cosine theta is equal to the adjacent over the hypotenuse, the square root of 2 minus x squared over the square root of 2, which is just equal to multiply both by the square root of both the numerator and the denominator by the square root of 2, and then you get the square root of 4 minus 2x squared over 2. So then this is equal to negative square root of 2 times, well, just leave it as the square root of 2 because it'll cancel out. Negative square root of 2 times the square root of 2 minus x squared over the square root of 2 plus c. And then the square root of 2 cancels out, and then we're left with this is finally equal to negative square root of 2 minus x squared plus c. And just like that, we found our integral.